welcome to lesson 4.4, Division with Decimals. Let's jump in with an example. Let's say 3 friends go out to lunch and the lunch bill comes up to $18.75. If they decide, instead of splitting up the check as into, hey Bob, you ate that, and Sally, you ate that, what if they decide to split the check equally? How much will each person pay? Well, that's a division problem. So what we're going to do is we're going to divide 18.75 divided by 3. And if we figure that out, it's going to be $6.25. Now we can think about this logically. We have 75 cents. Well, that's 3/4, so each person has to pay a quarter. And 18 divided by 3 is 6, so each person has to pay $6. Now, that example we can kind of do in our head, we can do logically. But if our numbers are a little bit more complicated, we should have a process how to figure this out. So let's run through this process. I'm going to give you the example of dividing 5,974 by 20. And we're going to start off like regular long division. 20 goes into 59 2 times. 2 times 20 is 40. Subtract the 2. 59 minus 40 is 19. Bring down the next digit, which is 7. Now, 20 goes into 197 9 times. 9 times 20 is 180. Subtract the 197 and 180, we get 17. Bring down the 4. Now, 20 divided into 174 goes in 8 times. 8 times 120 is 160. 174 minus 160 is 14. But at that point, my original number was done, 5,974. But I still have 14 left over, and we don't want a fraction. So what we're going to do, add the decimal at the end of the number, and tack on a placeholder of a 0. And I can have as many of these zeros as I need. And place a 0 and pull it down, just like it was already there. So now 20 goes to 140 7 times. 7 times 120 is 140. And then 140 minus 140 is 0. And we don't have to go any further. So we're going to continue this process of adding a 0 and doing our division until we reach a 0 or our decimal starts to repeat. And what I mean by that, we start seeing 1, 1, 1, 1, or 7, 7, 7, or 1, 2, 3, 1, 2, 3, 1, 2, 3. As soon as we see a repeating decimal, we can stop. Let's try another problem, but this time one of our numbers already has a decimal. So let's try 34.7. So our dividend has our decimal divided by 4. Now the first thing that we want to do when we set up the problem is our decimal, we want to carry it up to our quotient. That's the first thing I do, bring it straight up. And then we have 4, then we just treat it like a normal long division problem. 4 goes into 34 8 times. 8 times 4 is 32. 34 minus 32 is 2. We bring down the 8. We don't need to bring down the decimal because the decimal is not going to be in our working space. It's just going to be in our answer. So we bring down our next digit. 4 goes into 28. 7 times. 7 times 4 is 28. 28 minus 28 is 0. We can stop. So our answer is 8.7. So line up the decimal, divide like whole numbers. And if I had to add a couple zeros at the end until it was either repeating or it stops, terminates, then that's what we do. We can check our solution. 8.7 multiplied by 4. 4 times 7 is 28. Write down the 8, carry the 2. 4 times 8 is 32. Plus 2 is 34, write down 34, and then we just need to handle our decimal one space over, move over to the left one, Therefore, our answer is 34.8. That was our original dividend. Therefore, check. We did a good job. Here's our rule. To divide a decimal number by a whole number, we do the usual long division as if there were no decimal point involved. But the decimal point in the dividend is placed directly above in the decimal for the answer. So here's what I mean by that. I want to divide 49.896. So 49.896 divided by 27. My first step is to set up the problem. 27 divided into 49.896. I am going to immediately put my decimal point in my quotient, my answer, right above where it is. Now I'm going to start my long division like normal. And I do apologize, I've lost my pen, so I'm trying to do it with a mouse, so if it comes out a little weird looking, I apologize. So let's try my writing with a mouse. 27 goes into 49 once. So 27. Subtract. That's going to be, if I can do my math, 22. Bring down the 8. Now, 27 goes into 228. Well, let's see, 9 times 7 is 56. It's going to be 18 plus 5. That's too much. So it's going to be, my decimal point went away there. Let's try 8. 8 times 7 is 56. Carry the 5. 8 times 2 is 16, plus 5 is 21. Subtract. 8 minus 6 is 2. 2 minus 1 is 1. 2 minus 2 is 0. That is the worst 2 I've ever seen. There we go, 2. Bring down the 9. Okay. 27 goes into 129. Let's try 5 times. Let's try 5 times. 5 times 7 is 35. That would be too much because 5 times 2 is 10 plus 3 is 13. That's too much, so it's got to be 4. 4 times 7 is 28. Carry the 2. 4 times 2 is 8 plus 2 is 10. 9 minus 8 is 1. 2 minus 2 is 2. All right, bring down the 6. And 27 goes into 216 8 times because I did it in the problem, so I do know it's 8 times. And that's 216. And 216 minus 216 is 0. There we go. So our solution to this, our answer is 1.848. Ugh, writing is horrible, but I do apologize for that. But you can see the process, how it works through. All we do is place the decimal right above where it is in the dividend in our answer. And then we're going to do our long division like regular. Let's try one more example. 35 into 1,139 and 9/10. Okay, first step, I place my decimal where it needs to be. And then I start my division process for long division like I normally would. 35 goes into 1. It doesn't go into 11, so I have to do the 113. Well, let's try 3. 35 times 3. Well, 3 times 5 is 15. Carry the 1. That looks like it works. 3 times 5 is 15. Carry the 1. 3 times 3 is 9, plus 1 is 10. Subtract is going to be 8. Bring down the 8. All right, 35 goes into 88 twice. 2 times 35, 70. subtract. 88 minus 70 is 18. Bring down the 9. Remember, we don't have to bring down the decimal because this is our working space. And we've already handled the decimal in our answer. 135 into 189. Let's try 5. 5 times 5 is 25. 5 times 3 is 19 plus 2 is 17. That will work. So 5, that's 25. Carry the 2. 15 plus 2 is 17. 9 minus 5 is 4. 8 minus 7 is 1. Now, although our number in our dividend right now stops, I still have some numbers to go. So I'm going to just add a placeholder of a 0, bring it down like it was already there, and now start my process again. 35 goes into 140. I'm going to say 4 times. Oops. Here we go. Say 4 times. 4 times 5 is 20. Carry the 2. 4 times 3 is 12 plus 2 is 14. That's about the worst one I've ever seen. And then that is a 0. And I'm done. So I've hit the 0 and I'm done. So my solution here is 1,138 and 9/10 divided by 35 is 32.54. In our previous examples, all of the divisors, the number we were dividing by, all of the divisors were whole numbers. When the divisor is a decimal, we do need to do one more step. So let's take an example of 31.35 divided by 3.8. Now I can set that up as a fraction, 31.35 over 3.8. And if I multiply both of these numbers by 10, well, 10 over 10 is just a 1, so I can multiply something by 1, and it won't change the solution. It might change how it looks, but it doesn't change the solution. 31.35 times 10 is going to be 313.5, and 3.8 times 10 is 38. Now, our divisor is a whole number. So this number on the bottom, if we were to set it up like a fraction, must be a whole number. Now we can do a decimal by a whole number, our division. Bring up the decimal point, exactly where it is, bring it up straight up, and then 38 goes into 313 8 times. 8 times 38 is 304, subtract the 2, we get 9. Bring down the 5. 38 into 95 goes twice. 2 times 38 is 76. 95 minus 76 is 19. Now we don't stop there because we have a 19, so we're going to put in our 0, bring it down. 38 goes into 119 5 times. 5 times 38 is 190, so 190 minus 190 is 0, and we can stop. And then we can also check our solution. 8.25 times 38, and if you run through this process, you do get our solution of our dividend of 313.50. Now our original didn't have that 0 hanging on the end, but that 0 is just a placeholder in a decimal when it is at the end, so I can cut it off if I need to. But it doesn't hurt to have it there. So here's the full summary about division with decimals. First, we divide decimals by the same process we use for whole numbers, but the decimal point in the answer is placed directly above the decimal in the dividend. Remember, place it directly above. We are free to write as many zeros after the last digit in the decimal as we need, and then if the divisor is a decimal, we can change that into a whole number by moving the decimal to the right as many places as necessary, so long as we do the same to the dividend. Let's attempt another problem. This time we're going to divide and we're going to round our answer to the nearest place, position, this time to the nearest hundredth. So what I want to do is I want to carry my quotient, my answer that I'm getting, out to the thousandth position. And then after my thousandth position, I can stop, even though I might not be done with my division. That's okay, because I'm going to round, but I need that thousandth position to be able to round my hundredth position. So I have 0.3778 divided by 0.25. The problem arises when my dividend, my divisor has a decimal in it, and indeed my divisor does have a decimal. So I'm just going to move it to the right 2 spots, and then it would be a whole number. But what I do to the divisor, I must do to the dividend. So let's move that 2 spots. Now, my decimal point will be straight up between the 7 and the 7. And then I'm going to use my long division. I won't run through it. You can see it right there on your screen. Until I get to the thousandth position. Once I get to the thousandth position, remember it's tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. Okay, once we get to the thousandth position, I can stop, even though I still have numbers that I can divide into. So I have 1.551, and we're going to round to the nearest hundredth. We look at the thousandth position. If that is 5 or more, 5 or greater, we're going to round up. Our hundredth position will round up. If it is less than 5, then we will round down. We will truncate it. We'll just cut it off. In this case, 1 is less than 5, so we can just chop it off, and our solution would be 1.51. So let's, you and I, try one. We'll divide and round to the nearest tenth. 17 divided by 3/100ths. So my first task to do is to make sure that what I am dividing by is a whole number. So I'm going to move my decimal places 1, 2. If I do that, 1, 2. Now, because my decimal goes right there, because I'm rounding to the nearest tenth, I am going to need a couple of zeros. Okay, now that we have that placed in, let's start working with our numbers. 3 goes into 17 5 times. 5 times 3, remember that's just a 3 now, is 15. 17 minus 15 is 2. Bring down the 0. 3 goes into 20 6 times. 3 times 6 is 18. 20 minus 18 is 2. Bring down the 0. Okay. 3 goes into 20. Lo and behold, it goes in 3 times again. 3 times 6 is 18. 20 minus 18 is 2. Bring down the 0. You can see there is a pattern going on here, but I'm just going to continue with the math. 3 goes into 20 6 times, 18, subtract the 2, 20, bring down the 0. 3 goes into 20 6 times, subtract 18, 2, and I'm done because I have enough placeholders to be able to round. Alright, so my quotient is, whoa, sorry about that. I think I got my mouse a little crazy. fuzzy there for a second. 566.66. All right, we are going to look at the 100th position and see if we need to round our 10th position up or down. Well, 6 is greater than 5, so we will round up. So it's going to be 566. Point, add 1 to the 6, 7. And that's it. That's how we round. So we look at the next position to the right. If it's greater than 5, we round up. If it's less than 5, we round down. If it's 5 or greater, we round up. If it's less than 5, we round down. In essence, we truncate. So you might ask, when would you ever use this? Well, you'll actually use this probably quite frequently because our money, when we write it down on paper, always has decimals. Unless you're just working with whole dollars, when you deal with the change portion of it, the coin portion of it, that's in decimal. So you'll be working with this quite a bit over your lifetime, I'm sure. So let's take an example. If a man earns $8.26 an hour and receives a paycheck for $309.75, how many hours did he work? You might be asking, when will I ever divide decimals into whole numbers into decimal or decimals into decimals? Well, you probably do it over your lifetime a lot because our monetary system, our money, is in decimals. When you write money down, as long as you have coinage there, it's going to be in decimal. So if you have only dollar bills, that's going to be in whole numbers. But when you have any change there, that's the decimal part. So you'll probably use this pretty frequently. Let's try an example. A man earns $8.26 an hour and receives a paycheck for $309.75. How many hours did he work? This is a division problem. You divide the amount he makes per hour into his total paycheck, and that will give us the hours he worked. Let's set up the problem. 8.26 divided into 309.75. And I'm just going to tack on a few zeros just in case we need them. My first step is my divisor must be a whole number, and right now it is not. So I need to move my decimal place over twice. What I do to the divisor, I must do to the dividend. Now my decimal place is right there. Otherwise it would be between the 9 and the 7, and that is just not the right location. So we do need to move it. Now that we have that set up, we can start doing our division. Now we have 826 divided into 3, nope, 30, nope, 309, nope, 3,097. That looks like it might go in 3 times. 3 times 6 is 18. Carry the 1. 3 times 2 is 6 plus 1 is 7. 3 times 8 is 24. Subtract. Need to borrow. 17 minus 8 is 9. Oops, that was a big 9. 8 minus 7 is 1, and 30 minus 24 is 6. Bring down the next digit, 5. All right, 826 goes into 6,195. Let's try 7. Why am I choosing 7? Because 7 times 8 is 56, and that is less than the 61 that's hanging out here. So I'm going to guess that it's 7. And if it's not 7, I'll erase and try maybe 8 or 9 or whatever it may be. So 7 times 6 is 42. Carry up 4 this time. 7 times 2 is 14 plus 4 is 18. Carry the 1. 7 times 8 is 56 plus 1 is 57. 5 minus 2 is 3. 9 minus 8 is 1. Got to borrow here. 11 minus 7 is 4. Bring down a 0. Okay. Now, I'm looking at this 41, and a 5 times an 8 would give me a 40, so I'm going to try a 5. Might be too much, but let's try a 5. 5 times 6 is 30. Carry the 3. 5 times 2 is 10, plus 3 is 13. Carry the 1. And 5 times 8 is 40 times plus 1 is 41. Oh, good. It was not too much. In fact, it was perfect. So we know a man that earns $8.26 an hour and receives a paycheck for $309.75, he worked 37.5 hours, which would be 37 and a half hours. Let's try another example. A telephone company charges 43 cents for the first minute of a telephone call. So if you pick up the phone, dial your mother, say hello, and you hang that up, that's 43 cents. Then all the other minutes after that first minute will be 33 cents. If your call cost $3.07, how many minutes did you talk? How long was the phone call? Well, here's how there's lots of ways to solve this problem. I'm going to kind of not necessarily take it out of the math realm, but I'm going to try and do this logically. We know we talked for at least 1 minute, right? Because our phone bill, our cost, was $3.07. So I'm going to subtract, I'm going to take this 307, so 3.07, I should probably be doing this off to the side, let's see, 3.07, and we're going to subtract that very first minute that we talked because we know that's 43 cents of our bill. 0.43. Now I have 7 minus 3 is 4. I have to borrow. 10 minus 4 is 6. And 2 minus 0 is 2. So we know that the remaining minutes of our phone call, that was $2.64. And each one of those minutes was at 33 cents a minute. So that's a division problem. I'm going to divide. Let's just get rid of that. I'm going to divide 33 cents into the remaining amount of money, which was $2.64. So 0.33 divided into 2.64. But 0.33, I don't want it to be a point. I don't want decimal out there as a decimal number. I want it as a whole number, so I'm going to move the decimal 2 spaces. It's not always 2 spaces, but in this case it was 2 spaces. What I do to the outside, I need to do to the inside. Here's my decimal. And I don't think I'll need this 0, but I'm just going to put it there as a placeholder. Because minutes are usually just whole digits. They are integer numbers. Now I have 33. Divided into 2, no. Divided into 26, no. Divided into 264. Let's see. 30. Should we try an 8? 8 times 3 is 24. Let's try an 8. Oops. I want that in blue. That's about the worst 8 I've drawn yet. 8 times 3 is 24. carry the 2. 8 times 3 is 24, plus 2 is 26. Oh, look at that. Oh, good. 0. So we know at the 33-cent charge, we spoke for 8 minutes. But you can't forget that first minute for the 43 cents. Therefore, our total phone call was 9 minutes. 9 minutes long. So if we take off that first minute, then we can divide the rest of the money by our secondary charge, our 33 cents, and get how many minutes the phone call was at the second rate, and then make sure that you add in the first minute that you had. Now, in where I am, California, there is a difference between calculating a GPA, a grade point average, for high school and college. In high school, what you do is the grade points are still the same. An A is worth 4 points, a B is worth 3 points, a C is worth 2, a D is worth 1, and an F is worth 0. And in high school, let's say you took algebra, chemistry, English, and history, and you got a B, a C, an A, and a B. What you would do is you say, oh, a B is worth 3 points, a C is worth 2, so that's worth 3 points, 2 points, 4 points, and 3 points. And you add all of those up. 3 plus 2 is 5, plus 4 is 9, plus 3 is 12. And you divide that by the number of classes that you had. So you had 4 classes, you divide that by 4. 4 goes into 12 3 times, so you have a 3.0 GPA in high school. In college, it's different because not all classes have the same unit amount. And because of that, the unit will, depending on how many units, that grade will be weighted more or weighted less. For example, if you got an A in a 1-unit class, that shouldn't be the same weight as an A in a 5-unit class. I mean, the 5-unit class was, I'm going to say, number one, a lot longer, had more workload involved, and maybe it was more difficult. You know, maybe you took an appreciation of looking at paper for 1 unit, and then you took chemistry for 5 units. Well, the appreciation of looking at paper was probably less strenuous, less rigorous. Well, it was certainly a faster class to take. I don't want to dumb down 1-unit classes. There are some really great 1-unit classes out there, and there are some easy 1-unit classes out there. And I suppose I could say that for 2 and 3 and 4 and 5-unit classes, but pretty much all the 5-unit classes I took were pretty hard. Anyway, here's how you calculate your GPA for college, at least in California. Let's say you still took an algebra class, you took a chemistry class, you took an English class, and you took a history class. But the algebra class is worth 5 units, 5 credits. Chemistry is 4 credits. English, 3 credits. And history, 3 credits. You still got the same grades. In algebra, you got a B. In chemistry, you got a C. In English, you got an A. And in history, you got a B. Well, here's how you figure out your grade point average. You take the number of units, multiply it by the value, the letter grade value. A B is worth 3 points, so 5 times 3 is 15. C is worth 2, so 4 times 2 is 8. And A is worth 4 points, so 3 times 4 is 12. A B is worth 3 points, so 3 times 3 is 9. You add all of those points up, you get 44. Then you add up the total number of units, number of credits you took. Well, 5 plus 4 is 9, plus 3 is 12, plus 3 is 15. You took 15 units. So 44 divided by 9. If you do the division, I'll show you the whole long division there, you're going to get 2.93333, the 3 stop. So we can say you have a 2.93 GPA. A 2.93, we do not round, that is definitely different than the 3.0. So I just want you to be aware, if you need to calculate your GPA for high school, that's one thing. If you need to calculate your GPA for college, that's another. So that's it for this video. Thank you very much for tolerating my mouse writing, and until next time, be seeing you.